Have you ever wondered where everything came from? The vastness of the night sky, the twinkling stars, the planets orbiting in their celestial dance, and even us, standing here on Earth, gazing up in awe. I mean everything. The stars, the planets, even you and me. All the matter and energy that make up our universe had to come from somewhere, right? It's a big question, one that has puzzled humans for centuries. Ancient astronomers and philosophers pondered the origins of the cosmos, creating myths and theories to explain the mysteries of the universe. Today, we have a pretty good idea of the answer. Thanks to the advancements in science and technology, modern astrophysicists have pieced together a fascinating story of our universe's birth. It all started with a bang, a really big one, but not just any bang, the Big Bang. We call it the Big Bang. This monumental event marks the beginning of everything we know. Imagine everything in the universe squeezed into a space smaller than a pinhead. All the galaxies, stars, planets, and even the building blocks of life, compressed into an unimaginably tiny, hot, and dense point. It was incredibly hot and dense. Temperatures soared to unimaginable levels, and the density was beyond anything we can experience on Earth. Then, about 13.8 billion years ago, something amazing happened. This tiny point exploded. But it wasn't an explosion in the traditional sense. It wasn't an explosion like a firework, though. It was more like a rapid expansion, a sudden and dramatic stretching of space itself. Instead, it was a rapid expansion of space itself. This expansion happened at an incredible rate, faster than the speed of light, in a process known as cosmic inflation. The Big Bang wasn't just an explosion of stuff into space. It was the creation of space and time itself. Before the Big Bang, there was no space, no time, no matter, and no energy. It was the beginning of space and time as we know it. From that moment on, the universe began to expand and cool, allowing the formation of particles, atoms, and eventually, stars and galaxies. Everything that exists today, from the tiniest atom to the largest galaxy, came from this single event. The Big Bang set the stage for the evolution of the cosmos, leading to the rich and diverse universe we see today. It's a pretty mind-blowing idea, but stick with me. The story of the universe's birth is filled with wonder and discovery, and it only gets more fascinating as we delve deeper. It gets even more interesting. As we continue to explore the cosmos, we uncover more secrets about our origins and the incredible journey that has led to the universe we inhabit today. In the first moments after the Big Bang, the universe was unbelievably hot and dense. Imagine a space so compact and energetic that it defies our understanding. This was the birth of everything we know, a moment of pure creation and unimaginable energy. It was like a giant cosmic soup, filled with energy and particles we can barely even imagine. This primordial soup was a chaotic mix of fundamental forces and particles, swirling and colliding in a dance of creation. The energy levels were so high that particles were constantly being created and annihilated. Think of the hottest thing you can, then multiply it by 1 billion, and you're still not even close. The temperatures were so extreme that normal matter as we know it couldn't exist. It was a realm dominated by pure energy, where the laws of physics as we understand them were just beginning to take shape. As this incredibly hot soup started to cool down, something remarkable happened. The universe began to expand, and with expansion came cooling. This cooling allowed the energy to start transforming into something more familiar to us. The energy began to transform into matter. This process, known as nucleosynthesis, was the first step in the creation of the universe's building blocks. It was during this time that the first protons and neutrons began to form. This wasn't just any matter, it was the building blocks of everything in the universe. These particles would eventually come together to form the first simple atoms, primarily hydrogen and helium, which are the most abundant elements in the universe. Protons, neutrons, electrons. These tiny particles would eventually come together to form atoms, the basic units of matter. These atoms would later combine in various ways to form the complex molecules that make up stars, planets, and even life itself. This early universe was a chaotic and rapidly changing place. The forces of nature were in a constant state of flux, and the universe was expanding at an incredible rate. It was a time of great turbulence and transformation. It was nothing like the universe we see today, filled with stars and galaxies. The early universe was a hot, dense fog of particles and energy with no distinct structures. Over time, gravity began to pull these particles together, forming the first clumps of matter. But within this chaos, the seeds of our universe were being sown. These clumps of matter would eventually become the stars and galaxies that populate the universe today. The process was slow and gradual, taking millions of years to unfold. The Big Bang was not just a destructive event, it was also a creative one, setting the stage for everything that was to come. It was the beginning of a grand cosmic journey, one that would lead to the formation of galaxies, stars, planets, and eventually, life itself. The universe, in all its vastness and complexity, started from these humble beginnings. After the initial explosion, the universe didn't just sit still. It was a dynamic event that set everything in motion. It kept expanding, and it's still expanding today. This expansion is a fundamental aspect of our universe, constantly pushing the boundaries of space. It's like blowing up a balloon. Imagine holding a deflated balloon in your hands. As you blow air into it, the balloon gets bigger and bigger. The surface area increases, and any marks or dots on the balloon move farther apart. In the same way, the space between galaxies is stretching, carrying them along for the ride. This means that galaxies are not moving through space, but rather space itself is expanding. This expansion isn't just happening at the edges of the universe, it's happening everywhere. Every part of the universe is experiencing this stretching of space. Imagine dots drawn on the surface of a balloon. These dots represent galaxies. As you inflate the balloon, all the dots move farther apart, even though they're not moving on the surface itself. This is a great analogy for understanding how galaxies move apart without traveling through space. That's how the universe's expansion works. It's a continuous process that has been happening since the Big Bang. But here's something really cool. This expansion has some fascinating consequences. As the universe expands, it also cools down. This cooling process is essential for the development of the universe as we know it. Remember that incredibly hot cosmic soup? In the early moments after the Big Bang, the universe was a seething, hot plasma. As space stretched, the energy density decreased, causing the universe's temperature to drop. This cooling allowed particles to slow down and combine to form atoms. This cooling was crucial because it allowed for the formation of more complex structures, like atoms, stars, and eventually even planets and life itself. Without this cooling, the universe would remain a hot, chaotic place, unable to support the intricate structures we see today. Over billions of years, this process of expansion and cooling has shaped the universe into the vast, complex cosmos we observe now. Galaxies formed, stars ignited, and planets coalesced, creating the diverse and dynamic universe we are a part of. The universe's expansion is a testament to the incredible forces at play, constantly driving change and evolution on a cosmic scale. It's a reminder of the dynamic nature of the cosmos and our place within it. As we look up at the night sky, we are witnessing the ongoing story of the universe's expansion, a story that began with the Big Bang and continues to unfold with each passing moment. Section 4. From Chaos to Cosmos, the Formation of Matter. As the universe continued to expand and cool, the tiny particles created in the Big Bang started to clump together. This wasn't random clumping, though. It was driven by gravity, a fundamental force that pulls matter together. Gravity acted like an invisible sculptor, gradually pulling these particles into larger and larger clumps. Over millions of years, these clumps grew into massive clouds of gas and dust, called nebulae. These nebulae were the birthplace of stars, the building blocks of galaxies. Imagine yourself standing on a hypothetical planet billions of years ago, gazing up at the night sky. Instead of twinkling stars, you'd see these enormous swirling clouds of gas and dust. These nebulae were like giant cosmic construction sites, where the raw materials of the Big Bang were being assembled into the structures of the universe we know today. Section 5. Stars ignite, the dawn of light. Within these swirling nebulae, gravity continued to pull matter together. As the gas and dust compressed, they heated up, getting hotter and hotter. Eventually, the temperature and pressure at the center of these collapsing clouds became so intense that a remarkable transformation occurred: nuclear fusion. Nuclear fusion is the process where light atoms, like hydrogen, are forced together under immense pressure and temperature, fusing to create heavier elements like helium. This process releases an incredible amount of energy, the energy that powers the stars. The first stars were born in a blaze of glory, illuminating the early universe with their brilliant light. These stars were massive and short-lived, burning through their fuel quickly and ending their lives in spectacular supernova explosions. But in their death throes, they seeded the surrounding space with heavier elements, paving the way for the formation of even more diverse and complex objects.